Boundary binary search. Also called binary search on the answer or predicate binary search. We have a range of possible answers and a yes/no check. We binary search to find the smallest or largest value for which the check passes. Use it when the predicate is monotone. For small x the check fails and for large x it passes, or the opposite. Then the valid values form one block and we find its boundary. You need a cheap way to check. If we use x, can we achieve the goal? What we're doing, we're not searching a sorted array for a key. We're searching for a number x, the answer, in a range from low to high. We have a check. If we use x, can we achieve the goal? The check is cheap to run for any x. For small x the check might say no, for large x it says yes, or the opposite. So there's a boundary, one side all no, the other all yes. We binary search, pick mid, run the check. If yes we try to go smaller or larger, we narrow until we find the smallest or largest x that passes. Why it works, the monotone property, if x works, every value on that side works, so we can discard half the range each time. Example, finding the left boundary. We want the minimum x in the range 0 to 10 such that check of x is true. Here check of x is true when x is at least 4, so we have f above 0 through 3 and t above 4 through 10 and 11. We binary search, the teal segment is our current range from low to high. Each step we look at mid, if check of mid is true we shrink from the right, else we shrink from the left. Step 1, low is 0, high is 10. Mid is 5. Check of 5 is true, so we set high to 5 and shrink the range from the right. Step 2, low is 0, high is 5. Mid is 2. Check of 2 is false, so we set low to 3 and shrink from the left. Step 3, low is 3, high is 5. Mid is 4. Check of 4 is true, so we set high to 4. Step 4, low is 3, high is 4. Mid is 3. Check of 3 is false, so we set low to 4. Now low equals high, so we stop. The answer is 4, the smallest x in the range for which check of x is true. R is the size of the search range, t is the time for one check. We do logarithmically many iterations in R, each iteration runs the check once. So total time is O of log R times t, space is O of 1 for the binary search loop, plus whatever the check uses. Pseudocode for the left boundary, the minimum x such that check of x is true. We maintain low and high, each iteration we take mid, run the check, and shrink the range. Function, left boundary of low, high, and the check predicate. While low is less than high, we haven't found the boundary yet. Mid is the floor of low plus high over 2. If check of mid is true, the boundary is at mid or to the left. So we set high to mid. Else check of mid is false. So we set low to mid plus 1. When the loop ends, low is the first value where check is true.